Hi everyone, in this video we'll discuss about selection sort. So selection sort is a sorting algorithm that sorts a list by repeatedly finding the minimum element from the unsorted part and putting it at the beginning. So we are considering the ascending order here. So the smallest element will be at the first. So in each iteration, the algorithm finds the minimum element from the unsorted part and places it in the sorted part. Let's see an example. So let's say this is the input array that we are given. So the algorithm will virtually divide the array into two parts. One is the sorted part and the other is the unsorted part. So initially in the unsorted part, all the elements will be present. So the algorithm will find the minimum element in the unsorted part and place it in the sorted part. So the minimum element here is 1. So 1 will be placed in the sorted part and the remaining elements are in the unsorted part. In the next step, we again find the minimum element in the unsorted part. So the minimum here is 2. Now we place this 2 in the sorted part. Now the minimum in the unsorted part is 3. So 3 will be placed in the sorted part. Now we have 4. So it will come 1, 2, 3, 4. Similarly, like this, at each step, we are adding one element in the sorted part. Then 11 will come, then 12, and then 15. So that is how we'll get the sorted array. So the algorithm is quite simple. We just need to compare all the elements, find the minimum element, and place minimum at the front. So basically we are selecting the minimum element and placing it at the front. So because we are selecting, that is why the name selection sort comes. So once we have understood the concept of the algorithm, let's see how we can write the pseudo code for this. So size of this array is 9. So in each iteration, we need to find the index of the minimum element which is smaller than array of I and between array of I plus 1 to array of size. So in the first iteration, I is at 0th index. So we need to find the minimum element from I equal to 1 to I equal to 8. So the minimum element in the array is 1, which is at 6th index, and this 1 is less than the array of 0, which is 3. So the minimum index is 1. So now we'll swap array of minimum index, which means array of 1, with array of I. So if we swap this 3 and 1, the array that we'll get is, so after the first iteration, this will be our array. Now in the second iteration, I becomes equal to 1. So I is at the first index, and now we need to find the minimum element between these two indices. So the minimum element here is 2. So the minimum index is 5 because 2 is at 5th index. So we'll swap array of 5 with array of I. So we'll swap 2 and 15. So the array that we'll get is, so now in the next iteration, I comes at second index. So now we'll need to find the minimum element between these two indices. So the minimum element here is 3, which is less than 6. So the minimum index is 6 because 3 is at the 6th index. So now we'll swap array of 6 with array of I. So the array becomes 6 will be swapped with 3, and in the next iteration I will come at third index. So now we'll need to find the minimum element between these 5 elements. So the minimum element here is 4 because 4 is less than 11. So the index is 7. So we'll swap array of 7 with array of I. So the array becomes 11 will be swapped with 4 and the array becomes this. And in the next iteration, I comes at the 4th index and we'll need to find the minimum between these 4 elements. So the minimum is 6, which is at the 6th index. So we'll swap array of 6 with array of I. So the array becomes 12 will be swapped with 6, and in the next iteration I comes at 5th index, which is pointing to 15. So now we need to find the minimum element between these three elements. So the minimum element is 6, which is at the 8th index. So we'll swap array of 8 with array of I. So the array becomes 15 is swapped with 6, and in the next iteration I comes at the 6th location, which is pointing to 12. And now we need to find the minimum element between 11 and 15. So the minimum is 11, which is at the 7th location. So we'll swap 11 with 12. In the next iteration I comes at 12, which is at the 7th index. So now we need to find the minimum element which is smaller than 12. So there is no element which is smaller than 12 because we are left with only 15. So in this case 12 will be swapped with only 12, or we can skip the swap. So this step will remain as it is, and in the next iteration we'll get the final array. So this is our final sorted array. So in each step of the iteration we select the minimum element and swap it with the starting of the array. So this is how the selection sort algorithm works. So once we have understood the algorithm, let's look at the few important properties of selection sort. So the time complexity for selection sort is order of n square in all the cases, best, average and worst. Because we have basically two loops. In the first loop we run from I equal to 0 till the size of the array, and in the second iteration we find the minimum element. So for finding the minimum element we again have to compare with all the elements. So because of these two nested for loops, the time complexity remains order of n square. So even if the array is sorted, there will be no change in the complexity because at every step we'll still have to find the minimum element. So the complexity remains same, which is order of n square. So this is an in-place algorithm, which means it does not require any extra space. So the space complexity is order of 1. So selection sort algorithm is not stable because it changes the relative order of elements with equal keys. So let's say our array is like this. We have the first element 4, then we have 4, 2, 3 and 4, and then we have 1. So let's say this is our input array. If we sort it using selection sort, so we'll first find the minimum element out of all these. So the minimum element is at the last, which is 1. So this 1 will be swapped with the first element. So 1 will come here, and then we'll have 2, 3, 4 and 4. So here you can see that this 4 comes at the last. So now we had two equal 4s, but the relative order has changed. The 4 which was occurring before is now occurring at the end. So because we are swapping the elements in each iteration, the relative order of the elements can change, which are equal. So that is why this algorithm is not stable. And the last property is online. So the selection sort algorithm is not online, which means that if we receive a stream of elements, selection sort won't be able to sort it as we keep on adding new elements, because in each step we have to find the minimum element. So if we receive a continuous stream of elements and if we receive a smaller element later, then the algorithm won't be able to put it in the right position, because it needs to know in advance which is the minimum element that is there. So it is not possible to sort it if the elements are not known beforehand. So it cannot sort a list as it receives it. So these were the few important properties of selection sort. Now, so once you've understood the algorithm and know about all the important properties of selection sort, let's look at the implementation. All the source code that I'll be showing is available in my GitHub repository, link of which is present here and as well as in the description. Now let's have a look at the code. So in the main function I have this vector, which is the input array which needs to be sorted. Then I call this function selection sort. In this function selection sort, in the outer loop I run through all the elements, and in the inner loop I find the minimum element. So the minimum index will store the index of the minimum element. So after this inner for loop, we'll have the index of the minimum element, then I swap it with the element present at the ith location. So this minimum index is initialized with the ith element. So if there is no element which is lesser than the ith element, then minimum index will store the element which is present at the I location itself. So the swap will have no effect in that case. But otherwise we'll swap the minimum element with the element present at I location. So after these two for loops end, then the array will be sorted and in the main function we'll print it. Let's see the output of this program. So the input integer array is given here, and when we sort it using selection sort, it is sorted. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.